Hello everyone. Today's topic is nature of roots, which is a continued topic of quadratic equation. So our equation is the standard form of quadratic equation is ax square plus bx plus c equals to 0, which means it gives us two roots. By using the formula, we can say that alpha is equals to minus b plus under root t upon 2a, or you can see that other root will be beta, which is equal to minus b minus root t upon 2a. Now what is d? D is equivalent to b square minus 4ac. We can tell the nature of root by this d. This d helps us to find the nature of the root. We have three conditions like d is greater than 0, which means d is positive, d is equals to 0, and d is less than 0, which means d must be negative. So what happens when my d is positive means inside the root, if I have a positive number, so our roots will be 2 real and distinct. Distinct means different from each other. If one's answer will be 4, so the other's answer will be 5 or something else. If my d is equivalent to 0, which means the root is skipped from here, so we can say that 2 equal and real roots, which means whatever we have d either equals to 0 or positive. In both case we have real root, which means this one is non-real because d is negative number, and we know that whenever we have negative number inside the root, it means it was an imaginary number. So we can say that 2 non-real roots. Now moving a step ahead to understand these for their conditions, like what we have 2 reals and distinct, which means d is not perfect square. And when it happens, when d is not perfect square means whatever we have 4 plus minus root 96 upon 2 is my equation, is my quadratic equation. So what can we say? That d is not a perfect square, which shows that d is equals to 96. This one is not a perfect square number. So what are the conditions that for the roots? How can I tell that the roots are real and distinct? So we can see that d is not a perfect square and these conditions will be happen. So we can say that a and b both belongs to rational. A and b both are rationals. If they are rational, so it gives the answer as irrational. Irrational and conjugate. How we can say that it was irrational and conjugate? Because it involves root, so it makes as irrational, and the conjugate with the means same equation with the opposite sign, one with the positive and one with the negative. Now come to the second one. What this one tells us? This tells us two equal roots and real roots, which means whatever the answer would be same. So we can say that if my quadratic equation is quadratic equation is perfect square, which means if I have x square minus 4x plus 4 equals to 0, which means it will be x minus 2's whole square, or you can say that plus 2 whole square will be a perfect square. So whatever we have x plus 2 equals to 0 and x plus 2 equals to 0, which gives us x equals to minus 2 minus 2, which means we have both values are same, which shows that we have equal root. And this kind of equation, this kind of solution, this kind of roots will be known as one solution. It has one solution but two roots. Okay, the difference between this and that is that it has two solution and two roots. This one has one solution and two roots. Now for the third one, when our d is negative, so we can say that if a b belongs to real number, over here they are saying q, which means rational. Over here they are saying r, which means real number. If a and b are real number means either my a and b will be rational or irrational. It may be both. Okay, so we can say that the roots are conjugate complex. Now what is complex? Complex means imaginary, which means we have root with the negative sign, or you can say that it will be in form of a plus ib or a minus ib, which shows one with the plus sign, one with the minus sign. It means they are conjugate to each other. Now we have a simplest question to understand the nature of roots is the equation 3x square plus 4x plus 6 equals to 0 has two real roots, no real root, one real and one imaginary. This will not acceptable because either both are reals or both are imaginary, or you can say that not real. So this will not happen. C is skipped from the answer. Applying the formula of d, which is b square minus 4ac. The value of b is 4 minus 4 a and c. Square of 4 16, 4 into 3 24, 4 into 3 12, 12 into 6 72, and after subtraction we will get minus 56. So d is negative when d is greater than 0. So we can say that no real roots because d is negative. So option B is our right answer. Our next question is, if the roots of equation x square minus 8x plus a square minus 6a equals to 0 are real and distinct. When they are saying that we have real and distinct, it means d is greater than 0, which means d is positive. Then find all possible values of a. Now we have to find the values for a, where according to the equation, this one is my a, this one is b, and the other one is c. By applying the formula, which is b square minus 4ac is greater than 0. So the value of b is minus 8 square minus 4a, and the value of a is c is a square minus 6a is greater than 0. The square of 8 will be 64 minus 4a square minus 6a greater than 0. In both terms we have 4 as common. 4 16 minus a square minus 6a is greater than 0. 4 is multiplying over here. When it shifts to other hand, it will be divided and will be 0. So we can say that 16 minus a square plus 6a greater than 0. Now this one becomes a quadratic equation, a general quadratic equation, and you can simply find the values of a. Tell me in the comment section that what will be the values of a in this equation. Okay, tell me in comment section what are the values of a, because it's become a general quadratic equation and you can simply find the values of a by using factorization method. Now moving towards a little bit difficult question. If one root of equation x square plus bx plus 12 equals to 0 is 4, means an equation has two roots. This one is one root, you can say that alpha, while equation x square plus bx plus q equals to 0 has equal roots, means both equation having same roots. Then value of q, we have to find this value and they are giving us the options. So what we can do, we can simply say roots satisfy equation. So we can say that x square plus bx plus 12 equals to 0, where the root is 4, so the square of 4 will be 16 plus 4p plus 12 equals to 0. 16 plus 12 will result as 28. 4p is equals to minus 28 and the value of p is minus 7. While we have another equation is x square plus bx plus q equals to 0. If one root is my 4, so other root will be minus 7. So we can say that x square minus 7x plus q equals to 0 is my new equation. By using d is equals to minus b square minus 4ac will be equivalent to 0. So we can say that b square 7, so the square of 7 will be 49 minus 4ac equals to 0. 49 minus 4q equals to 0, or you can say that minus 4q is equals to minus 49. So what will be the value of q? The value of q will be 49 upon 4, because this 4 is multiplying when it goes to another hand, so it will be written as q is equals to 49 upon 4. This one will be the value of q. See, just applying the basic rules and what we learned in our previous videos, that roots satisfy the equation and both are same, both equations have same roots, so we can simply find the value of q. Now this question is very interesting and little bit difficult from the previous questions, that both the roots of the equation x minus b into x minus c plus x minus c into x minus a, x minus a into x minus b equals to 0. This one is our equation are always, they are asking for the roots, either the positive, negative or real. So first of all, just sort out the equation. What is this? X into x will be x square minus bx minus cx plus bc plus x square minus ax minus cx plus ac plus x square minus ax minus bx plus ab equals to 0 हो जाएगा. Then this one we have x, this one is x, this one is x, and all are adding to each other, so it will be written as 3x square minus bx, and we have minus bx, so we can say that 2bx. cx minus cx, so we can say that 2cx minus ax and minus ax, so we can say that 2ax. Taking 2 common from all of them and writing a plus b plus c and taking x as well as common, because we have bx, ax and cx, plus the remaining will bc plus ac plus ab equals to 0. Now this one is our quadratic equation. To seeing this equation, we have to tell that what are the roots of this equation. The formula of d is equals to b square minus 4ac. So our b is minus 2a plus b plus c. So the square of 2 will be 4 and a plus b plus c whole square minus 4a and c. Now over here a plus b plus c, we have to apply a formula. Formula is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Minus 4 into 3 will result as, or you can say that in both terms we have 4, so we just take 4 as common, so the remaining will be 3. Minus 3 bc minus 3 ac minus 3 ab, which result as 4 into a square plus b square plus c square minus ab minus bc minus ac. And we learned in our previous classes that it will be equivalent to 1 upon 2 a minus b whole square added by a minus c whole square plus b minus c whole square, which is greater than or equal to 0 always. So we can say that d is greater than or equal to 0. Okay, which we learned that this one will be equivalent to this formula and this will be greater than or equivalent to 0. So we can say that d is greater than or equivalent to 0, which means our answer should be C, which means our roots will be real. Either they are distinct or equal, but they are real. So another amazing question. Find k such that x square minus 2 minus kx plus k minus 2 upon 4 becomes a complete square equation. So when it will be a complete square equation, which tell us that d must be equals to 0, which we learned in the start of the topic, that whenever our quadratic equation is a complete square, so it will be must 0. Okay, so applying the formula, which is b square minus 4ac equals to 0. To find the value of k, the square of b, the value of b is 2 minus k square minus 4a, and the value of c is 4 cancel out by 4, and written along with this 4, you can see that after taking the LCM. Over here we have to apply a formula of a minus b whole square. So the a square minus 2ab plus b square minus 4k minus minus plus, and this one will be 2 equals to 0. What happened just over here, this 4 will be multiplied by 4k and this will be multiplied by 2 upon 4. So when 4 multiplied by k, so it will become as 4k. When 4 multiplied by 2 upon 4, so they will be cancel out the numerator and denominator, will gives us only 2. Arranging the quadratic equation, k square minus 4k minus 4k plus 4 plus 2 equals to 0 will result as k square minus 8k plus 6 equals to 0. So to get the value of k, we have to apply a quadratic formula because it cannot be solved by factorization method. minus 8 plus minus 4a and c upon 2a. It will be as 8 plus minus the square of 8 will be 64. 4 into 6 will result as 24. 8 plus minus, you can see that 40 upon 2. Now the factors of 40, we can say it like 4 into 10 will result as 40, and 4 is a perfect square, so we can write it like 8 plus minus 2 root 10 upon 2, where 2, 8 and 2 both are the factors of 2, so we can also write it like, taking 2 as common, 4 plus minus root 10 upon 2. So the value of k will be equals to 4 plus minus root 10. As you see, we are applying the basic information using the nature of root, get the answer of k. Now we have a little challenging question. If L and M are real roots and L is not equals to M, then show that the roots of this equation are real and unequal. Real and unequal means d is greater than 0, you can say that positive. Applying the formula, which is b square minus 4ac greater than 0, or you can say that equals to 0. The value of b is 5, so the square of 5 is 5 square. L plus m square minus 4, the value of L minus m into 2, 4 into 2 will result as 8, and L minus m equals to 0, greater than 0. L minus m and L minus m both are same, so we can write them as L plus m whole square minus 8 L minus m whole square. Now by seeing this condition, we all know that whenever we find the square between the difference of two numbers, it always will be greater than 0. It always will be greater than 0, and we learned it in previous question. So we can say that L plus m square and L minus m square both greater than 0, so the roots are real and distinct, or you can say that unequal. See, by using the simply knowledge what did we learn in our previous classes and previous question, that L minus m, the difference between two numbers, whenever we are taking the square, it will be always greater than 0, because we are finding the square, and in the question they are saying L and m is not equal, so we know both are different numbers. If one is 0, so other than not a 0, and they are also telling us they are real roots, it means they are more than 0. Now in this question, what are they asking? Form a quadratic equation, means we have to write a quadratic equation with rational coefficient having 1 plus root 3 as one root. According to this condition, we learn when d is greater than 0 and having rational coefficient, which means a and b belongs to rational number, then our answer should be conjugate. If this one is my one root, so the other root should be this one because of conjugate. We learned that if my root is irrational, so the other root will be irrational conjugate. Okay, so by using this one, if this one is my alpha and this one is my beta, so what would be my equation? We can use two methods over here. Number one, x square plus sum of x plus product equals to 0, which is in standard form. So sum between both of them will be 1 plus root 3 plus 1 minus root 3. Plus root 3 cancel out, minus root 3 equal to sum 2. And what will be the product? We have to multiply both of them. 1 plus root 3 multiply by 1 minus root 3. 1 into 1 gives us 1. 1 multiply by minus root 3 plus root 3 multiply by 1 plus root 3 plus minus minus root 3 multiplied by root 3 will gives us 3 into 3 plus root 3 cancel out by minus root 3. 1 minus 3 will result as minus 2, which means our equation will be x square plus 2x minus 2 equals to 0. Minus 2x, because in the standard formula we have minus sign. Okay, so what will be the other method? Other method tell us that what we have, 1 minus 1 plus root 3 is equals to, for example, x. So we just have to move this one to other hand. So it will be root 3 is equals to x minus 1. Now we have to remove this root sign, so taking the square on both hand, so it will become 3. This one is x square minus 2ab plus b. To get the value or to get the equation, what we have, x square minus 2x plus 1 minus 3 equals to 0, and the equation will be 2x minus 2 equals to 0. So in both conditions we get the same equation. One method we learned from our previous lectures, and we know that if one root is irrational, so other will be its conjugate. We learned this from previous lectures about the roots, and applying this one by learning the theory of equations, that the standard form of equation will be x square minus sum of x plus product equals to 0. Now this one is another interesting question in which they are asking for evaluate value of x cube plus 3x square plus 2 at x is equals to 1 plus root 2. We already know the equation, the quadratic equation of this one, which we learned in previous question, but instead of using division theorem to write a quadratic equation into the product, into the quotient and get the answer, if we using simple logic to solve this equation, like x cube plus 3x square plus 2, this one is my equation, and we have to put x is equals to 1 plus root 3. 1 plus root 3 cube plus 3, 1 plus root 3 square plus 2. Now over here we have to apply a plus b whole cubes formula, and 1 plus root 3 over square, over here we have to apply a plus b whole square. But if we will see that it will be distributed in 1 plus root 3 square into 1 plus root 3 power 1 plus 3, 1 plus root 3 square plus 2. Now from these two terms, if I will take common, so it will be much more easy. Instead of applying the formula of cube and square on both of them, I just have to apply a formula of square at once. So taking square terms as common, 1 plus root 3 square, the remaining one will be 1 plus root 3 plus 3 and this 2. Now over here I just have to apply formula of a plus b whole square instead of applying two formulas or getting 2 or 3 equations by using the division theorem. A square plus 2ab plus b inside the bracket 1 plus root 3 plus 3 plus 2. Remember, these two brackets are multiplied. Once they multiply to each other, then we will add 2. 1 plus 2, root 3 will not be added, so we have to add 1 plus 3. 1 plus 3, 4 plus 2 root 3. 1 plus 3, 4 plus root 3 plus 2. Now this 4 once multiplied by 4 and once multiplied by root 3. When 4 multiplied by 4, it gives 16. When 4 multiplied by root 3, it gives 4 root 3. Now this 2 multiplied by 2 root 3 multiplied by 4 will gives us 2 into 4 gives us 8 root 3 plus 2 multiplied by root 3 into root 3. So it will gives us 2 under root 3 into 3 plus 2. 16. Now these two are like. How we can say like? Because both having same root value. So we can add them. 4 plus 8, 12 root 3 plus 2 into 3 plus 2. Because now this one will be solved. So what we get? 16. 2 into 3 will result as 6. 6 plus 2, 8. 8 and 16 it gives us 24 plus 12 root 3 is our answer for x cube plus 3x square plus 2. See, we get the answer by applying the value, and it will take a minute less than that. Instead, we are finding the equation for this one. For 1 plus x cube, we have to find the quadratic equation, we have to find the divisor and the dividend quotient as well, and remainder will be our answer by using the division theorem. But if we were applying a little bit trick, so we can save much more time and doing the question in the same way.